Welcome to Lecture Online. In this video we're going to take a look at some basic symbols that you might encounter when we look at circuits in this course. The symbols represent real devices. Of course, the symbols are not really true picture representation of those, but when you get used to symbols it becomes as if you're looking at the real thing. Here we have a resistor. A resistor is simply a squiggly line going back and forth like that. The resistor, the symbol that we use for resistance is R, and the units we have for resistance is ohms. We use the symbol, the Greek letter omega, to indicate ohms. That's the unit of resistance. When you have two lines together like this inside a circuit, this is called a capacitor. That represents two capacitor plates very close to one another, opposite to one another like that. This is called the capacitance, and the units we use is farads, and the letter for that would be F. Inductors or coils are drawn like little springs like that on the side. L stands for inductance, and the units we have for inductance is henries. We use the letter H for henries. Sometimes we have what we call the load resistor. We have an entire circuit and we attach another device onto that circuit. That device usually has some sort of resistance, and we call that the load resistor. It's not really part of the circuit. It's simply we load the circuit with this device or with this resistor. So it's called the load resistor, and we have a sub L to indicate that that's the load resistor. Just like a resistor, the units are ohms. We use the Greek letter omega. Sometimes we have what we call variable resistors. Resistors that we can vary, so we can vary the resistance of the resistor. We draw a little arrow through that that indicates that the resistor can be changed in value. We also need to have power sources or voltage sources. In this case, we have what we've drawn here, a battery. A battery is a series of lines, long and short lines. Where the long side starts, that's where the positive side of the battery is. Where the battery ends with the short line, that's where the negative end of the battery is. Sometimes we also call the battery the EMF, the electromotive force, because it basically forces current through the circuit. We use the letter V to indicate volts for the battery, and that's also then the units. The units and the symbol for the battery is actually the same. We use volts. We can also have variable capacitors. In some circuits we can vary the capacitor, and therefore we have a capacitor symbol with a little arrow through it. Some other things that we need to know is sometimes we have not just a steady state or direct current voltage source, sometimes we have an alternating current voltage source. An alternating current voltage source produces an alternating voltage. It increases, decreases, goes negative. Actually, the voltage becomes positive, negative throughout its cycle. So it produces what we call AC voltage, and we have this sine wave symbol inside a circle to indicate that. We also will be dealing with certain solid-state devices. A transistor is one of the simplest form of solid-state devices. We have a current coming in, another controlling current that determines how much current will come out of the device. We'll learn more about transistors. Another solid-state device is a diode, which basically only lets current through in one direction, not so much in the other direction, maybe just a small amount of lead current. So a diode indicates what direction it will allow the current to flow. And finally, we have something what we call connection to ground. This is a ground connection. We have a series of small lines that get shorter and shorter and shorter. That means when your circuit is connected to ground, the voltage will be zero at that location, and that then becomes your reference voltage of the circuit. Those are just some basic circuit symbols that we'll be using throughout. And so to be familiar with these is very useful, very beneficial to become familiar with these symbols. There's many more symbols, of course, but if you know these, you have a good repertoire of things that you can draw on when you start building and looking at simple circuits. And that's where we start.